You know, in the world of software engineering, sometimes a single quote, just one sentence, can unpack an entire philosophy. So today, we're going to dig into one that's, well, it's pretty opinionated, a little feisty, and it gets right to the heart of a huge debate about the right way to build software.
Okay, so here it is. Fear not, this is Rust, not some scruffy, loosely typed, garbage-collected language. Now, this isn't just some random comment on a forum, right? This is a bold statement. It's like drawing a line in the sand, separating two completely different ways of thinking about code. So let's break down what's really going on here.
So that quote throws around this word scruffy. What does that even mean? What makes a programming language scruffy in the eyes of someone who loves Rust? Well, to figure that out, we've got to deconstruct this thing piece by piece.
All right, let's kick things off with the first jab it takes at these so-called scruffy languages. This whole idea of being loosely typed. This is a really fundamental concept in programming, and it's at the center of a debate that's been going on for, well, a very long time.
So, what's the deal with loosely typed? Well, to put it simply, it's a language where you can create a variable and put a number in it. And then, later on, you can decide to put a chunk of text into that exact same variable. No problem. It's super flexible, kind of like an all-purpose box that can hold whatever you want to throw in it.
And here's where you can really see it in action. On the left, in a loosely typed language, the variable happily switches from being a number to text. It's all good, but look at the right side. In Rust, the compiler just says, nope, and throws an error. It stops you dead in your tracks before the program can even run, and that is the whole point. Rust enforces these strict rules right from the get-go to prevent a whole class of bugs from ever seeing the light of day.
Okay, moving on to the next keyword in that quote, garbage collected. This gets us into something super important that's happening behind the scenes, how a program actually manages its memory. And trust me, this has a huge impact on how your application performs.
So garbage collection, or GC for short, it's basically like having an automatic cleanup crew for your program's memory. As your code does its thing, it creates data. And when it's done with that data, the garbage collector comes along, finds all the stuff that's no longer needed, and frees up that space. For a lot of developers, this is awesome, right? Because you don't have to think about it. It just happens. But, and there's always a but, right? Here's the catch. To do its job, this automatic cleanup crew sometimes has to hit pause on your entire program. They're often called stop-the-world pauses. Now, for most apps, you'd never even notice. But if you're building something that needs every last drop of performance, like a game engine or a high-speed trading system, these little unpredictable freezes can be an absolute deal-breaker. And that unpredictability, that's part of the scruffiness this quote is talking about.
So that begs the question, right? If Rust avoids using a garbage collector to get away from those pauses, what in the world does it do instead? How does it keep its memory clean without a cleanup crew?
And this is where Rust gets really unique. Its answer is this system called ownership. It's a set of really strict rules that the compiler, not a runtime process, checks for you. The big idea is this. Every little piece of data has one and only one owner. And the moment that owner is done with the data, boom, the memory is cleaned up. Instantly, automatically. So you get this super predictable, deterministic performance. No pauses, no waiting for a cleanup crew.
Okay, so let's tie this all together. How do these two big ideas, strict typing and this whole ownership thing, add up to that fear not philosophy we saw in the beginning?
See that fear not at the start of the quote? That's really the punchline of the whole philosophy. It's all about putting your trust in the compiler. The idea is that by making you deal with all these strict rules about types and memory right at the start, the Rust compiler catches a gigantic category of common bugs before your code even gets a chance to run. You're basically trading a little bit of upfront effort for some serious long-term peace of mind.
And what you end up with isn't just a random box of features, it's a really clear, coherent philosophy. The goal is to catch errors early when they're cheap to fix. It's about giving you, the developer, precise control over memory so you get that predictable performance. And, at its core, it's about trading that upfront strictness for rock-solid reliability down the road.
And this is probably the most important takeaway. That aggressive tone in the quote can make it sound like a personal attack, but it's much more useful to see it as a passionate argument for a different set of trade-offs. Loosely typed, garbage-collected languages often prioritize speed of development and flexibility. Rust, on the other hand, prioritizes performance, safety, and control. It's not about one being universally better than the other. It's about choosing the right tool for the job you're trying to do.
So I want to leave you with this final thought to kind of chew on. As people who build things with code, we're constantly making choices about our tools. So the real question is that upfront discipline that a language like Rust demands worth the freedom from those scruffy, hard-to-diagnose bugs that might just pop up later? It's a fundamental question about how you want to build things in this digital world.